on integrating sustainable practices into its design-driven work. And Stas is actually born and raised in Ireland of Polish parents before coming to the US to study at Columbia. In other words, he's a very typical New Yorker and American. He's an early member of New York Passive House and serving for a number of years as vice president and now president. He's active on the AIA Committee on the Environment. He is on the Energy Code Advisory Board to the Department of Buildings for the 2020 and 2016 Energy Code adoptions, and is currently serving on the Climate Mobilization Board, and is actually one of the co-chairs on the multifamily. And if that's not enough, he does really beautiful work. So I would love, with that, I would like to hand it over to Stas. Thank you.
Sounds good. Okay, well, thank you both for the introduction. It's a real pleasure to be here today talking about my two favorite topics, passive house and mass timber. And interestingly enough, they both took off in various manners around the same time in the mid-90s, even though there were aspects of both of these mass timber and passive house projects in preceding years. So it was interesting to hear about that or find out about that in our kind of studies. So I'm going to be talking about energy, embodied energy, and operational energy. I'm going to be talking about different mass timber aspects, a case study project that our office conducted that had some interesting results, and then talking about the impact and other aspects of timber and mass timber and where it comes from, and how we can look at things from that perspective. I will also be talking about the newer some of the testing that has gone on that I was following quite closely over the last couple of years and the progress that is happening. So that's a quick overview. So just embodied and operational energy. So Passive House is very focused on operational energy, and all of the numbers that we put into PHPP, et cetera, are really all focused on that portion of the curve. And sometimes people criticize Passive House for not looking at the other aspect, which is embodied energy. But of course, since we're all kind of nuts about energy, we do think about it. We all know that. And we look at it as part of the equation, okay? So obviously these, you all probably know a lot about this in terms of the embodied energy and transportation, manufacturing, construction portion of it, and end of life, right? What is done with those materials and where they go. There is obviously huge variation in those process energy requirements that are happening from those different materials, from wood all the way up to glass, mild steel, stainless steel, and then aluminum, which is kind of off the charts. So interesting to find out that there were some studies done when the first Passive House was done in Darmstadt, Germany, that the embodied energy accounted for about 20% of the total lifetime energy use of that project. And we'll be diving in a little bit more detail in this, but I thought it was interesting when I started to research embodied energy a couple of years ago for these factors. And of course, there's a lot of information out there that varies. I mean, some folks are saying it's 25%. Other studies are saying it's 43%. It really varies. And both of these studies are looking at 50 years, right? And if we look at Architecture 2030, this is probably a slide that many of you have seen. And it is saying, well, we really should be looking at embodied carbon because it's pretty much equal to operational carbon. But what they're not, well, they're clarifying here, but we have to note that this is just based on 30 years, okay, 30 years comparison. And obviously that curve is going up and up and up. And if we look at, I hope the buildings we are all designing and building, or most of us, apart from some temporary buildings and the like, that we will have those buildings for a lot longer than that. So if we look at that curve, well, you know, many of us live in 100-year-old buildings. I think we should be considering the whole pie. So how can we address this in the designs that we're doing nowadays? We can look at passive house because it makes the most, and it capitalizes on all of the aspects of our buildings in terms of orientation, airtightness, materiality, thermal bridges, all of those aspects. And as we go up the scale and make those buildings better and better, we only have a limited requirement to bring in renewables, right? It's no use building a terrible building and then putting a ton of renewables on it. The whole goal is to be economical in reducing that energy use of that base building. And so we can apply that thinking to that passive house thinking to embodied energy, about looking at man-made energy. So looking at the Darmstadt project, that first project built in the mid-90s, or early 90s, I should say, the structural core of that building was accounting for pretty much half of the embodied energy, primary energy of the building. And that's a substantial number. So when we saw that, we said, well, this is where these other aspects can come in. But of course, there's other things. I mean, this is also taken from Architecture 2030. And interesting that, you know, they're looking at these materials, wool, straw bale, hempcrete, as being carbon negative. Obviously, that's a big foray in terms of the 50% of the structural aspect of a building accounting for the embodied energy of that whole building. So mass timber is a viable alternative. And if we look at, this is an interesting thing that we found recently. It's a 1923 in 1923, some guy looked to invent this new way of using wood lumber, and this patent was developed, and they were basically the idea of taking these timbers, putting them at 90 degrees to one another, and then they were sending them through a series of rollers, and they were compressing the wood so they would bond. And it was interesting to see this as a typology. I guess it didn't really take off back in those days. So nowadays, mass timber is really referring to all sorts of different products. There's composite typologies, NLT down at the bottom here, which is nailed laminated timber, LVLs, LSLs, glued laminated timbers, DLTs, which are dowel laminated timbers, which don't have any glue, and CLT. CLT is by far the product that is getting the most attention, probably because of its rapid rise in use in a lot of these larger buildings and larger projects. But all of these are a family of products that, and new ones are coming out all the time. Folks are like the MPP typology is evolving, and all of these types are evolving. So let's see. I see someone saying, does the shared screen appear slightly blurry to anyone else? My screen is pretty. It's not blurry at all. So
yeah, we clarified it. It's all.
Oh, you clarified. Okay. So I'll keep going. So so nowadays the CLT that is being used is a really different product. So to the 1923 invention, in that it uses glue to bond all of these different layers. And there's a huge potential for structural capacity with this product. And as I was saying earlier, it was also developed in the early 90s in Austria. It's very, very efficient in its production. This is actually the Nordic factory up in Chibougamau in northern Canada, and I went to visit this factory as part of a study that I did, and it was pretty amazing to see the whole process. So the land that they have, and they have millions of acres, they are just using 2 or 3% of the land in terms of what they were taking down, and they were just they were not clear cutting, they were taking down specific trees, and then it went into this machine here at the bottom left-hand corner, and there were lasers that were, this tree trunk is twisted around in about half a second. The lasers register the profile of it, and then it automatically calculates the sizing, the maximum output of what they can get out of that log. And all of this happened in about literally 2 or 3 seconds. So it was then shot out to the side, it's cut down in these sizes, and then in terms of this whole process, they would take all of the rest of the bark, and all of that was used in a kiln drying for the product. And so all of that process was all happening right there and then. And then in a building next door, they were producing all of the CLT, the glue lam, all of these different products. So the photograph at the top of the left-hand corner is actually of a different organization, but it shows you one version of how this press is done for the CLT. This is why, based on what we've just seen in terms of this process, why we have such radically different numbers in terms of the embodied energy that goes into these products. You can see how engineered wood of all types is so much lower. And then we prepared this slide because a number of our clients were asking us about embodied carbon and how it works. And we kind of brought it down to this diagram in terms of the trees capturing all the carbon, the trees die, and then that CO2 is released. And really what we're looking to do here is we're looking to, that CO2 goes into those trees, and then we use those trees in terms of construction. So we're sequestering that carbon. And there's a huge difference in terms of what we're saving in terms of carbon emissions, which is really the pressing issue of the day. All right, if we do a passive house, we are locking into low energy use over the years, which is great, but we need to attack the big elephant in the room, which is carbon emissions right now. So the other thing about mass timber compared to a lot of the materials we're using is its R value. So it's efficiently produced, it has low embodied energy, it sequesters carbon, and it has a very high R value compared to some of the other materials we use for structure, CMU, steel, and concrete. And if we look at our passive house, our favorite passive house wall types with higher R values, we have a CMU type wall, or could be concrete, cast in place concrete with rebar versus a steel structure or CLT. We're looking at very consistent thermal lines throughout the assemblies, and we're also looking at added R value because of these. So you can notice that these CLT walls are a little bit thinner than the other ones with the same R value. And then in terms of therm diagrams, in terms of the progress of heat flow through these junctions, and you have to remember, wherever you have a floor that's meeting a wall, you're going to have differences, and you're going to have a thermal bridge of some type A lot of times people think of thermal bridges as only happening in a balcony or something that protrudes that insulation. But anytime that wall varies in consistency, i.e. at a floor, you have a variation of heat flow. This diagram pretty much shows it very well. So how much of an impact can this have on the life cycle carbon emissions? So we did a study a couple of years ago on, started a couple of years ago on a project, and we were looking to see what the differences would be. So we were fortunate to have a project where we had two very developed sets of drawings and details for both types of structures. So a concrete structure, cast in place, reinforced slabs and columns, and a shear wall circulation core, and then the CLT structure that had structural wall panels and then flat floor slabs spanning all the way over. And I see some questions coming through. I will get to those a little bit later as we go through this. The two different wall types, CMU, sorry, this is actually a C block. A C block has a higher insulating value than CMU or concrete, and that was used as the infill. And so what we did is we used the Athena modeling software to model these two different types. And so the Athena system is quite straightforward to use. I would encourage all of you to look at these. If it's any consolation, if any of you have learned PHPP, this is super easy compared. And it basically outlines, you put in all the data for the different buildings, for the different products that you're using in your building, and you get the output of the different stages, right? So life cycle stages of your building. So the product, the construction process, the use, the total operational energy, which is a separate number that we get from PHPP. We have end of life and then beyond end of life. And then the two categories there, the CLT and the concrete. Interesting to look at these. So obviously in these two comparison case studies, we have the same foundations. We're assuming the same foundations for each, even though it's often the case that CLT being much lighter than concrete, you can get away with less concrete. But for the moment, we kept it as the same, just to be conservative. And then a very big difference in the walls, columns and beams. Well, there are no columns and beams in the CLT. It's just the wall, the floor structure spanning over, and the floors and roofs. Yeah, I see questions about fire ratings. I will get to that a little bit later in this. So in terms of the results of this life cycle global warming potential, we have a number of columns here showing a non-passive house and what we would get in terms of the metric tons emitted in a concrete building versus a CLT building. The operational and the embodied is outlined here in terms of the light blue and the dark blue. Going to Passive House Classic, I mean, look at that drop. This is why we're all of you here are New York Passive House members and interested in these typologies. And then obviously going to Passive House Plus, which is a slightly better or slightly more, you know, better windows, a little bit better, more insulation, a little bit of PV to account for that. But we're looking at a huge 93% reduction from a concrete non-passive house building to a CLT Passive House Plus. So that's a huge reduction. This is over 80 years. I see a question here. Is it over 30 years? It's over 80 years. And I'll go into this a little bit more. So then we divided it up into the avoided greenhouse gas emissions, 170 tons, carbon dioxide stored in the wood, 550 tons, CO2 from passive house, 2,000 tons. You can see the relative differences of why it's important that we keep our foot on the gas pedal, so to speak, of doing passive houses, because overall, over 80 years, it's a huge, huge carbon benefit. So yeah, this is all done with Woodworks Carbon Calculator, Passive House Planning Package, and the EPA Carbon Equivalency Calculator based on an 80-year life cycle. So a lot of people are concerned about wood, and they view wood as cutting down our forests. And why should we be doing that? Well, the question is we have a lot of forestry around the world, and the truth is we are not really, we're not using it very well, and there's a huge capacity there. There are a lot of locations in Europe where their forestry is, I feel, a lot more advanced in terms of how they're using the forests, etc. And perhaps that's one of the reasons why CLT, CLT started off in Europe, so there's it's got a couple of years of advances on us. Now, this is interesting. This is the Yale forestry study looking at harvesting, and approximately 20% only of the forest's annual growth potential is being used. So in this study, they looked at, well, if you increase that to 34%, that would mean quite a substantial reduction in global CO2 emissions. 14% of global emissions is huge just with this increase. And of course, with all of these things, it's really, really important that we look at maintaining biodiversity. So it's important that we don't just plant forests with the same type of trees, that we look at maintaining water purification and erosion control. So all of these different aspects that are listed here in this chart are very important. And that I think most important of these is that we have sustainable forest management. A lot of times today there's huge amounts of forests being clear cut for other uses, and that's a huge loss. So we did a presentation a few years, maybe two years back with Arup at the AIA conference, and Francis Yang spoke about this diagram, which is very interesting. So it shows how the different emissions above that zero line work with a concrete design versus the sequestration or cooling with a timber design. And you can see the growth as that tree gets older, still taking in all of the CO2 when it's manufactured. Some of it is, there is a certain amount of CO2 emitted, and then depending on the transportation, there's some variations there. Then of course, end of use, end of life, right? What happens to that building at the end? Is it demolished? Does it go to a landfill? Is it recycled? Is it reused? Incineration? All of these aspects affect the question. So what's interesting is that if we don't sustainably source our wood, it's really not that much, a little bit better than concrete, but not that much better, right? It's when you look at the delta between the timber design in sequestration from proper sustainable sourcing versus the lines above the zero line, there's quite a difference. Projections in the future in terms of we're aware of the impact if we don't do anything now, and there's a tremendous potential for mass timber and other aspects to to have on this equation. So this is not a, this is a kind of a projections that we came up with, but you can see the differences in business as usual versus the emissions peak and what we could do with mass timber. So I'd like to talk a little bit about the, so we won a grant to study mass timber, and we visited a number of projects in England. And in London, they have really, CLT has really taken off. So we went to visit a number of buildings that were being built. We talked to a number of architects who were building them. We met a lot of the consultants who were advising on this stuff, and they really opened our eyes to a lot of different factors. So this is a building in Neasden in London. It's 9 stories. I think they were adding 1 more onto it, but this went up in the matter of a month or 6 weeks. I mean, it was incredible, the speed. It was super clean. I mean, this site was just unbelievable. Some of the Sega tape that that they've added to this. And you can see the openings that were being made for the plumbing lines, and a project by Waugh Thistleton Architects. So Waugh Thistleton are very, very advanced in this world of CLT and other mass timbers. And this is a 10-story building in Dalston Lane. So I think this is the largest largest mass timber project in the world. And interesting to note that it's built over a railway line, and they couldn't only build something like 6 or 7 stories in masonry, and they were able to build more capacity with the CLT because it was much lighter. What was interesting is we toured the building, and I was in one of these units, and I was asking Andrew about, hey, do you know, I'm a passive house guy. I was just wondering if you know what air tightness this building is. And he goes, oh, yeah, we had to do that as part of the code. And it's got an ACH of 1.0. And I was like, oh. And interesting to note that they reached a 1.0. They didn't have any passive house kind of requirements or anything, but they did that without even kind of thinking about it. You can imagine what they could have gotten if they had, put a bit more tape or checked a certain amount of places. So it's kind of incredible what you can get. And you get that because you have this consistent wood barrier around your whole building, right? That's the way it's built, and that's the way it brings these loads down. So in terms of all of these, so coming back to the US, so there was an ad hoc committee that was created to investigate with this advent of these new mass timber products, how can we change the current codes for wood, because they're behind the times, okay? And so the ad hoc committee was created, and you may have heard of Susan Jones. She is an architect in Seattle, and she was selected to be as part of this committee, and a number of people, including fire engineers, fire consultants, a whole gamut of people were on this committee to investigate and to see and come up with a series of categories that the US could adopt. And this is just an image of a testing setup that was created as part of the ad hoc study to see how CLT would perform under different conditions. So what we have here is some photographs of these different conditions, and you can see that there's good old plastic or whatever furniture, lots of good stuff for toxic stuff that in a fire would produce a lot of crazy smoke and all that. And there would be a guy, and I was watching these live on a video at the time, and this guy would go to the very back, he would light a fire in the stove, and they would come out, and then you'd have this within no time at all. And you have to remember that these tests were set up that you know, a lot of people said, well, this thing is just going to go up in smoke and it'll be a collapse, and that didn't happen at all. So the 5 tests that were created were, the first one was all CLT surfaces were encapsulated in sheetrock. The second one, partially exposed CLT on the ceiling in the bedroom and living. And I'll show you a photograph of the panel coming out from after that test. And then exposed CLT on the walls in the bedroom and living room. And exposed CLT on the ceiling and walls in the bedroom and living room. So those tests were really a lot of exposed CLT there. And then the last test was the same exposed CLT, etc., but the sprinklers were delayed. So they were looking to mimic a situation in which there was a problem, sprinklers didn't go on immediately, etc., and how would it you know, fare. And so these are just photographs of the testing systems. There was a lot of monitoring to see what were the temperatures inside of here, and whether the CLT would fail, you know, if this whole structure would collapse. So this is the PRG 320 adhesive PRG 320 standard. So this is a standard that anyone interested in mass timber should be aware of, and it's a kind of standard requirement of for bonding strength, moisture durability, and all of that. So a lot of the different vendors are having to meet this and having to test their product. So whether it's a vendor from the US, from Canada, or from Europe, they are all getting their product tested for PRG 320 to be able to be used in the US. So here are photographs of the results of that test, of the fire tests, and you can see those exposed CLT portions. I don't have a slide of it here, but I think a lot of people who have shown mass timber and they talk about why you can use mass timber, and I don't have any slides on it here, but you're probably all aware that the principle is the outside chars and it creates a layer of carbon, and then that carbon protects the rest of the wood inside. So you oversize it, you build it to much higher thicknesses so that you can protect the wood inside. Some localized conditions and results of what you can see where the fire did get to the CLT and how it chars, but then kind of stops, a little bit like when you have a huge log in a fire. The code review process was really successful. I think the testing was incredible because with the results and the fact that things didn't fall down, and there was, you know, we've basically proven that even with the situations where there was so much exposed mass timber, things fared very well. All right. And so as a result of that, you know, sorry, I'm going back here, but basically the committee proposed 3 different types of mass timber, so of codes. So using these typologies, so there's type 4, 9 stories, type 4C is 9 stories up to 9 stories, then type B is up to 12, and type A is up to 18 stories. So we're talking about variations in how much protection we would have to provide, or you would have to provide for that building. So in the 9-story building, you can leave a lot of the timber exposed. In the 12, you can leave a certain percentage of it. And in the 18-story, it has to be completely encapsulated. So those changes were adopted and are going into 2021 IBC. And so that's great. It's unfortunately, it's not in New York State or in New York City yet. But for those of you working in the rest of the US or in other places, I think it's a huge, it's great that we've gotten this far with this committee, that we have these new codes and that they're being recognized. So that's a huge, we've come a long way in the last, 5 years, 6 years. However, we have some people who don't want mass timber to happen. And you've probably heard of these entities. It's called Build with Strength. I heard of these back in, I think, 2016, and I heard that at the time they had amassed $20 million to fight the mass timber community, and basically it's the concrete associations that are concerned with the rise of popularity of mass timber. I personally think obviously I think it's ridiculous, because we have so much need for construction. Concrete is still going to be used in many areas where you can't use timber. You can't, you have to build a base of a building in concrete. And we're not talking about, removing concrete at all. It's still going to be used in all sorts of places. But, there's a scare tactics going on. I think it's really sad. This is what they're showing, and this is very close to us. I mean, I was at an AIA event here in New York City, and Build with Strength were showing some stuff that they were talking about. They were undermining mass timber, and I think it's a problem, but it's the world we live in. This has also not helped the Grenfell fire, because there was no mass timber in this building. This is a concrete frame building, and as you all know, the insulation was not correctly specified or swapped out at the last minute, and it caught fire, and there was a number of mistakes that they made. But unfortunately, they've changed the rules in England for the insulation and the assemblies of exterior walls, and it's going to make mass timber much more difficult to build with. So that's unfortunately a byproduct of this, and there's a lot of politics when these new rules get done, and because mass timber still doesn't have enough percentage of use in different countries, even in England, there isn't enough political power to overturn these things. So I hope that they will be able to do that. So some recent developments, I wanted to just make people aware of that there's been a big uptick in CLT production in the US and Canada. Just the Nordic factory that I went to visit 4 or 5 years ago is suddenly gone from, running at 5-10% capacity to much higher numbers. So there's a huge amount of increase of interest in mass timber around the US, and some states have moved ahead, even ahead of 2021 IBC codes, and have already adopted some of these code code categories. So that's fantastic. Now in New York City, currently CLT is not allowed in the New York City code. However, my understanding is that it is going into, there's a structural advisory committee that has, or that is including it in their recommendations, and it will be in the new code. So that's good news. NLT, nail laminated timber, has always been in the New York City code, so that is always an option that is available. And as I mentioned earlier, there's a lot of different mass timber typologies, so you can think about that. So, what can we do? One of the reasons why Andreas, Caleb, myself, and many others are engaged in policy and that on Passive House is that there's only one way that we're going to change things. It's to get involved. I think it's really important, if any of you are interested in this in mass timber, is to get engage with these city officials and make them know that we are, compared to some states, we're behind, and there's no reason why we should be. I know that the New York City Buildings Department is very interested in mass timber, and they've been very supportive of any projects that we're looking to do. There are still challenges with the fire department, and that's a big hurdle to get over. So yeah, and then embodied energy. I think it would be good if we had some sort of understanding of what our embodied energy of our buildings that we build is, and there are places like Vancouver that are starting to account for this, and we learn a lot from how other cities are dealing with these things. We learn from each other.
So thanks Dash for the presentation. Yeah, so we would take a couple of the questions in the chat box, and my first question is, Stash, you are on the advisory board for the local law 97 here in the city. And I think local law 97 is a carbon law. Are you guys looking into embodied carbon or only the operational carbon of buildings?
Yeah, well, I think that the law is out there for everyone to read up on. I can't get too much into the specifics of what we're doing, but I can tell you that the law is specifically geared towards operational energy. It does not account for, as written anyway, the code does not account for embodied energy.
Mm-hmm. That's a very good question. Why the city wouldn't look into the embodied carbon? I mean, I think PHI or the Passive Institute is certainly looking into including some of the carbon embedded in materials as well. So
yeah,
interesting discussion.
It hasn't even really hit the international building code yet, so it's like an uphill slog right now. There is a bill on carbon purchasing in Albany right now, or concrete purchasing, that preferences lower carbon concrete purchasing, like giving in like certain bonuses, but there's really not a huge amount of movement in terms of embodied carbon yet.
There's an interesting question regarding if FSC certification is sufficient, in your opinion, to guarantee that sustainably, harvested wood, or how would you specify your timber?
Yeah, I mean, the FSC certification is pretty abundant in terms of where you're getting this. I think that there are some places in Europe that have different certifications, but the chain of custody is, my understanding is it's very important. And I think it's really good to, I mean, wherever I'm specifying my product, I ask the question. I say, well, I want to know how much percentage of your land are you dedicating, are you keeping intact? What's your proportion? I mean, I was surprised in the case of Nordic's situation how little they were impacting, how much capacity they had. And some of these, I mean, that part of Canada I think they were on a 30-year cycle for growing. And it's so cold up there that it grows quite slowly. But the interesting thing about CLT is and a lot of these mass timber products is because it's glued, they don't need huge, it's not using very large, big trunks of wood. It's quite, small. It's making big pieces with little pieces. So that's good because we are not necessarily having to use we aren't definitely using old growth timber or timber like that. And also the younger trees have a very high rate of absorption of CO2 at the beginning, and then it falls off. So you're kind of increasing the curve of CO2 capture in a way. But yeah, FSC is I think is a good starting point.
Can you actually repair a charred CLT?
Yeah, I think that's a good question. I had when I was in London, I was asking about similar question to that, but I was asking about water damage and things like that. And one of the architects I was speaking to had a problem with a water leak, and they basically got in additional CLT, and they adjusted it and put it into the, they were able to repair it. So it's like any, well, it's a little bit different to regular framing, but there's a certain amount of over design, and you can repair it in many different ways. So charring, I mean, it would depend on how much of the wood was charred, what the proportion of that wood was charred. If there's an overcapacity, and I mean, I've dealt with a project in New York City actually where we had a beam in a Tribeca warehouse that was in a fire, and we went through the process of measuring, well, what was the old beam, because there was a part that was not charred, and how much of it was charred, and is the remaining section, cross-section of wood sufficient to carry the load. So in that case, it was sufficient, so we didn't have to do that much to it. And in another place, we had to add a little bit of extra strengtheners. So it can be done with other things. I mean, if something like that happens to you, in our case, we added steel because it was thinner. So obviously there are different conditions or different situations depending on how much fire is happening, where you would be able to repair it with wood or with another material.
Let's see, back to water. David asked early on about, given the gradual transfer of energy, is there any issue with dew point in CLT?
Well, you're going to be dealing with, you're going to have to do the same analysis as with any other building material to make sure that you have your insulation in the right place and you have your air barrier in the right place. So, you know, we generally look to try and contain as much of the air movement and to put our air barrier on the inside. And the wood is actually a pretty good, it acts pretty well in that manner. So taping, that's why you saw the slides of the CLT being taped. And so it's acting as a form of air barrier. In terms of the dew point, well, you know, you have to do your analysis on that. But I generally try and put insulation on the outside, keep everything nice and toasty and warm, and I don't get any issues.
There's a question about shear walls and how those are being handled in the code, and he's saying, and Eric is saying, I'm learning that it's somewhat jurisdictional with some support in the 2021 IBC.
That question is pretty much over my head, as I'm not a structural engineer. But I mean, I can tell you that there's a lot of it's surprising how much shear stresses these CLT walls can take. And if you have these screws that are like this long, and you can basically screw the hell out of these CLT panels and use these, you know, brackets, and you can carry a lot of shear load through these structures. Sometimes you're going to see images of mass timber buildings with a concrete core, and that's sometimes done just because it's they wanted to get this approved quicker, so they're not going to go through that process, but the rest of the building is made out of mass timber. But the shear walls at a certain scale, you're able to take more than a lot of times what people think. And that's another issue, is that I think the structural engineering profession is also having to learn a little bit about this, because it's a different a different animal. I mean, it's like what we all have to do with Passive House, right? We have to brush up on what we were taught.
Stas, do you have an input on the cost CLT compared with concrete building, or for smaller single family like with a regular frame building?
Well, I can tell you first of all that I think we all have to make decisions if we want to use mass timber, whether we should be using it on smaller building typologies, because the whole point of using CLT is that it has a very strong structural capability. And we have to think about whether or not it is more efficient from a carbon point of view to be building with mass timber in a small building, that is, versus using regular studs, right? So that's one thing that it's not necessarily just like, oh, we should all just go and use this everywhere. That's not really the point. It's at the 5 to 8 or 10 stories, I think that it has real potential. That's the first kind of thing that's really important to note. The other part of your question was, sorry, I forgot. Other part of your question.
Well, if you compare cost.
Costs, yes, thank you. So what we are generally told that the cost in terms of the erection of these projects is approximately the same as concrete or steel. There is a very fast construction process once it comes to site. So that is where there's a huge amount of savings in the construction time period. There's also savings. I mean, you saw the photographs from the site, how clean it was. There's much less dust because we're dealing with just wood construction and it's prefabricated. So there's a lot of gains from that point of view. There's also gains from the point of view of, we've gone through a lot of increases of costs. I mean, all of us working in the city here, we've noticed the costs going up and up and up. And you're essentially doing some of that labor work outside of the cities. So it has makes a lot of sense in terms of helping jobs outside of the city and then bringing these prefabricated products in. And a lot of these mass timber buildings are being built with very, very few people. It's just a couple of specialized folks who know how to build this type of construction. So in terms of the costs, I think that it's very comparable. We are going to see a reduction in the costs because there's more competition, there's more factories out there doing it. And I believe it's less expensive than using comparable products based on my research and what I've been seeing.
Are there fire separation restrictions for CLT? So for example, can they be used for attached buildings?
For attached buildings? What do you mean by attached buildings?
So, basically zero lot line. That's what I'm assuming. Right.
Well, there are requirements in terms of what you can use. My understanding is that you need to have a separate wall that does not have mass timber in it. In other words, that you would have a structure, post and beam, and that you have a wall structure that is an infill wall structure that spans from floor to floor or something like that. And so, yeah. So that's part of the equation. I mean, in terms of other restrictions within the building, they vary in terms of the different heights of the buildings. And you can look a little bit more in terms of the code requirements within these categories, exactly what is required. So you can see here, the shaft weighs 40 minutes minimum inside and outside for type C. Type C is the lowest, up to 9 stories. Exterior side of exterior walls need 40 minutes. of protection. Top of the floor above the mass timber, there's no particular requirement of what we need on top, although I would put something. And then ceiling below the mass timber not required. And you can see those requirements increase as you go higher.
Yeah, I figured it must be something more or less like type C, like type 3 construction, like the existing heavy timber where, you've got a 2-hour rated, you need a 2-hour rated wall if you're up against an adjacent property. So like how you achieve that, it probably is more or less a similar kind of a situation that you have to have a UL rated construction of some kind to provide that.
Mm-hmm.
This is a really interesting one. Insuring buildings, like during construction as well as post-construction. Have any builders or owners had any issues with this? Because it's relatively new.
Yeah, no, that's a really good question. And it's a question that we were dealing with or asking when we went to England, and seeing all of these buildings being built. And there wasn't much of an impact in terms of the construction there. And it was interesting because all of the English folks were like, well, you guys build all with wood over there. So we're mostly other materials, masonry and things. So it's much more difficult or much more of a change. And they were making some interesting points. There was also there was only one fire that we know of that happened in construction. So the most risky period in construction of a building is in the life of a building is during construction. That's when most problems happen. And there was one mass timber building that did have some sort of fire happen to it. And I want to try and find out about where it was and what happened, but I was told that it was built as mass timber again. It wasn't changed. In terms of your question about insurance, it's a good question. I know that there are projects being built all over the place with these requirements, and what everyone is doing is providing this sort of required fire department requirements and more to satisfy not just the fire department, but any future insurance policy requirements. So I don't know if that fully answers your question. I think it's a good one, and I'm actively looking at those sorts of questions as bigger projects I see being built.
Yeah. There is a question about, will we need to educate people that write about the topic? So in other words, so that they have the proper way to discuss wood construction and not actually talk about wood construction, but mass timber and cross-laminated timber, because the journalism profession related to architecture isn't necessarily always up to date.
So I'm not sure of the question. Is the question, should we be educating?
Yes, the journalists basically. But I think it's sort of, and for me, actually, this question sort of bridges into general education, which is kind of one of the reasons you're doing this talk right now.
Yeah, I mean, I'm always like, will I talk about mass timber? Will I talk about passivhaus? And it's interesting because I talk on both, but it's definitely, mass timber has this attraction to it that is, let's just say, sexier or whatever than numbers and passivhaus, right? And you can see all of those images. I definitely have questions on how all of this stuff is left exposed, on these interesting variations of what I see in Europe versus here. And yeah, I mean, there is continually so many articles on this. We notice them, and it's going to require more and more of these building types to get built, and then to educate people. So you're right. That's a little bit why I'm doing this. And gradually people will understand, and they'll they'll see the reasoning of why these wooden buildings are safe. And it is really good to go and look at some of these fire tests to see how, I mean, it's not just the test done in the US, but there's some interesting fire tests done in Europe that folks have done, because they've gone through the same process, and you realize that that's not the issue with making buildings safe. So that's really important. And there's another interesting kind of dialogue that's happening, because there are some folks who feel like the race, because there's kind of a race to do the biggest, tallest wood mass timber buildings right now. And I think we're at 24 or 25 stories, something like that. And some people feel like that's really not what we should be doing, because it's taking the focus away from the sweet spot of the height of mid-range buildings that should be being built. And then others are saying, no, it's good to do this, because then people need to realize the extent of what mass timber can reach, so that we can convince and reach more people. So I don't really have an opinion as to who is right, but I think we need a little bit of both, in terms of creating some of those stunning, taller wood projects, and also developing a system for building some of these mid-range, mid-size buildings or mid-height buildings in our cities.
Well, we're over time, and I think we should let people go on their way. David Levine had one last question, which was typical floor spans that are possible with CLT.
So it will vary on whether you go, how many layers of CLT you want to work with. So in this particular project, we were going to a 7-ply, and we were going to span almost 25 feet with one piece. So you can get really far with one piece, but and obviously a 3-ply, a 5-ply, a 7, it's always unequal amounts of ply that are in these CLT products. But you have to make a calculation of whether it's more economical to put glulam beams and to do thinner amounts of CLT. What's more economical? But I would encourage everybody to look at Woodworks website, and they have a ton of really amazing webinars, and that will show you all of the things that I've shown you, plus way more. So I would encourage you to all access that. There's also a lot of really good PDF guides that have floor span tables, that have information on fire ratings, all of this stuff. It's really a fantastic organization, and they really want to help architects, engineers to incorporate these, so they're very helpful. So yeah, Woodworks.
Thanks, Dash, for that fantastic presentation. I think it's very important for us to think about the embodied energy, of course, and I think competition is always good. So the taller, the better, in my opinion. If it brings attention to the issues, I think that's always an interesting thought. So thanks, Stash, for the presentation. Thanks, Caleb, for participating in the Q&A, and thanks everyone for listening. And join us next Tuesday at 12 o'clock for Barry Stevens' ventilation presentation. Thanks, guys.
All right. Thank you.
Thank you. Bye.
Bye-bye.